Good morning, everyone. So today I'm going to show you how to use Excel to calculate a two-sample students t-test that is not paired. So what we'll be coming up with by the end is you should have an Excel workbook that looks exactly like this, with the exception, of course, that the labels will be different based on your data and maybe the number of trials, depending upon exactly what type of science fair experiment you are doing. So to get started, what I'm going to do is on this tab down here, I'm actually going to open up a new sheet. These are called sheets. And I'm going to do that by going in, right-clicking and going up to Insert. And then I'm going to insert a new sheet. And then you'll see now it says Sheet 1. The t-test is here. So you can toggle between the sheets this way. You can rename your sheet by double-clicking on it, and you'll get a highlight. So I'm just going to rename this one example so that you can follow along. When you open up a brand new Excel workbook, you'll just see Sheet 1, Sheet 2, and then a little plus. You can also add a new sheet by clicking on the plus, and you'll get a new sheet, and it'll just say Sheet 2. I'm actually going to delete that. Okay. Here's where we're going. So first, we need to make our table. That's always important to be organized in order to be able to have your data input in such a fashion that Excel can use it to do your calculations. So in column A, we always want to put our N number, where N is the trial number, and for this purpose, we're going to do through 10. T-test needs a minimum of 10 in order for it to be statistically valid. So you can do it this way. You can just type and then hit enter 1, 2, 3, 4, 5, 6. So that's kind of slow and boring. So instead, what you should do is you should type 1 and 2, left click and hold so that you have selected 1 and 2. And then if you hover over in the bottom right hand corner here, you see there's a green line, but then a green dot. If you hover over the green dot, your cursor will change from a white cross to a black cross. So if you left click once you have the black cross and hold it down, that's going to tell the autocomplete, hey, I'm counting and I'm counting by ones. Then I'll just drag it down and you can see the 10 there until I get 10. These are going to be my trial numbers. Well, then you also need to have your test labeled. So in this example experiment, we were looking to see if there was a statistically significant difference in the mass of these two different species of seeds, pinto beans and lentils. So the very first thing you should have in every single table is you should have your unit of measurement, which is mass, or a label of what you're measuring along with the unit of measurement, which we measured in grams. You have to put your units up here in the label and not down here where you actually write down the mass. The minute you put a letter into a box, then it changes that box, that cell, to be a text rather than a number, and Excel will no longer do calculations with it. So it's always best to have your units up at the top. It will also save you quite a lot of typing. Additionally, you want to always have the precision of your measuring instrument. So in my classroom, the scales are all quite precise, and this is actually located on the scale itself. If it's a digital instrument, it comes in the manual that came with your digital scale. So we're going to do plus or minus 0.003 grams. So in order to do that, so I've already typed in mass in grams. If I select that cell again, I can go up here to the top and just insert my cursor where I want to type in. So it's 0.003 grams, but I also need to insert the symbol plus or minus. You can do this by literally just typing in plus/minus if you prefer. You can see it there. Or, sorry, that was the bell. Or instead of doing the plus/minus, you can go to up here on the ribbons, you can go to the Insert ribbon and go to Symbols, and then click Symbol, and then the character menu will pop up, and you need to scroll through it to find the plus or minus. I've recently used it, so it's right here. But if you scroll down, it's just a couple of clicks down. There it is. So you can click it once and click Insert, or you can double click it. Either way, it will copy the symbol. You can close, and then there's my symbol. Okay. Then in each column, you will notice that I have, you know, in the row where I put the N, I have left a space that's not here with the trial number. So I need to put what the names of the seeds are. So I'm going to go with lentils and then also pinto beans. These are not the scientific names. Now you'll notice if I zoom in a little bit, okay, that we have the pinto beans are actually kind of hanging over column where column C is, and the mass as well over column B. So what we can do is come back and clean up that format. So one way to do it, if you watch the last video, is to hover between two columns, and then you can double click on the line, and then it resized to the column to cover my pinto beans. Or if I go backwards, you can click up here, highlight everything, and then double click in between, and then it will resize all the columns. And I actually like this way better because it also resized my end column for me. Now, if you look, now this mass label should actually be a table heading. So it should cover both of these columns, or actually all three of these columns. So to do that, we need to merge the cell. So if you left click in cell A1 and hold it and drag it between A1, B1, and C1, if you highlight all of those, you can go to the home ribbon. Right in the middle under alignment, there's a merge and center. So what this does is it'll take those three cells, it will put them all together as one, and then it will center the text for you in the middle. Zoom out a little bit. Okay, so then next, if I go back over here, okay, I need to input my data. So for my purposes, I'm just going to copy and paste this data. For you, you would need to actually type it in wherever you wrote that data down. Now you may notice as you're typing, you may notice when you type in 0.050 that it changes to this automatically. And if that's the case, what you should do is type in all your data, and then at the end, left click, hold and drag all of the data, and then toggle these decimal points up here. I also mentioned that in the last video. This hanging 0 is important. For scientists, IB in particular is looking for that when you take your exams, but that means that the scale actually measured to that decimal place, and it does have significance, so we do need to include those zeros. So all of my data is now here. Then what we're going to do is some simple, I'm actually going to resize this a little bit. You always have to include your descriptive statistics on your data analysis. So your descriptive statistics are going to be a measure of central tendency and a measure of variance. Those two have to be included in every single IA that you complete. So the measures of central tendency are mean, median, and mode. For your IA, mean is the one that we go with. You can include the others, but mean is going to tell you the most information about your data rather than the other ones. So we want to label. I'm going to just type in mean. I want to label the mean. And then also, we're going to include a measure of variance. And for our purposes, we're going to use standard deviation. There is also range, and there's variance, and there's a few others, but we're going to use standard deviation. So I'm going to label that here just underneath it, and I'm going to label it STDEV just for short. That's standard. Okay. So how do I get the mean? Well, the formula is to add up all of these values and then divide it by 10 because there are 10 values. So you could do this on Excel by typing equals, and you could type out all of those numbers. Like if I type out equals 2 plus 2, it would give me 4. But that's the slow way, and that's not using this software to its fullest capabilities. So what we need to do is we're actually going to go and insert a formula. So we're going to go up here. You want to select, first you want to select the cell where you want the mean to go, and then go up to the insert, to the formulas ribbon. You can go up to here, and there are some common formulas listed. And there are all sorts in here, but the formulas that we're going to use are here under more functions and statistical. But in biology, we use the math of statistics. So they do not call this mean, they call it average. But if you hover over it, you can see in the description, it is the arithmetic mean. So I'm going to click that, and up will pop a box. Okay, and that's going to tell me where do you want me to use data to calculate your mean. So it auto-selected B3 colon B12, which means everything from B3 through B12 in a column. So if you look, B3 is here, B12 is here. That is what we want. But sometimes the auto-select doesn't select it properly. So if it's not done properly, or if for some reason you don't have a preset there, what you can do then is just delete everything to make sure everything's gone out of this box, and then left click and drag to include every single box that you want. Later on, when you get a little bit more fancy, if you remember the formula, you can just type equals and average and type in the cells directly. It just depends on you. We're going to leave number 2 blank. Sorry, there's another bell. Then we're going to hit OK. And what that did is it returned an average of 0.050. If you look, though, in the function bar, you'll actually see the formula listed out here. And actually, that's a quick way your professors can tell if you're calculating this by hand or if you're actually using the functions argument. There's also another toggle switch that you could do. It's control tilde, where it will change, and it will show the formula in the cell as well as in the formula bar. And control tilde will put it back. Then we want to figure out the standard deviation. So you should do it the exact same way. You'll go up, you select the cell where you want your answer, then go up to the formulas ribbon. We're going to go to more functions and statistical. And then all of these formulas are in alphabetical order. So I'm just going to scroll down until we get to standard deviation. So if you look, there's actually several choices, and if you hover, it will tell you. So there's standard deviation P, S, A, and PA. So for our purposes in biology, we're always going to use, at this level anyways, we're always going to use standard deviation .S. And if you look at the description, this is the standard deviation of a sample. This is a sample because we did not measure every single lentil in existence at this time. We measured a sample of all the lentils that were in the classroom. So we'll hit that. And then you get the same box where you're going to input which cells you wanted to calculate from. This is the same for every single formula. So once you get used to this, I won't be repeating it anymore. So make sure this box is selected, and it didn't auto select any data for me. So what I want to do is I want to go back. I want to select cell B3 and hold it and drag it until I get to cell B12. Now, a common mistake that students make is to drag it all the way down, but that would be incorrect because B13 is the cell where we put our mean. We don't want to calculate the standard deviation and include the mean. The standard deviation should only be calculated using your original data. So make sure that it's B3 to B12, and you'll hit OK. And there you go. And you can see that the decimal points aren't correct. So the rule of thumb is based on significant figures. We can talk about that in another video. You can go back to the home page and then toggle these decimal points down. This one's actually 2 significant figures. Now, we can do the same exact thing all over again for the pinto beans column, but that's a little tedious, and there's actually a shortcut. So just like we did before, where we did the 1 and 2, and then we dragged down to get all the way to 10, if you click on the mean and you have the same green box and you hover over it with the black cross, if you left click while you have the black cross and drag it to the right while you're holding the left click down, what that does is it tells Excel, oh, you want to copy the formula, but you want to use the data that's in column C rather than in column B. In this example, it doesn't save a whole lot of time, but when you're dealing with sheets and sheets of data where you have 50 columns that you need to calculate, it is a huge time saver. And then you can do the exact same thing with the standard deviation. Just hover in the bottom right-hand corner until you see the black cross, left click and hold it and drag it, and there you go. And in this case, we should be 3 significant figures, and these are already correct for significant figures. There's our mean and standard deviation. Then that's our descriptive statistics. So I'll just type that in this box, descriptive statistics, just so that you can see. And then next we're going to calculate a 2 sample students t-test that is non-paired. Okay. So in order to do that, I will put a label that says t-test down here. I'm going to skip a line just to kind of show you that it's not part of the whole table. What a t-test will do, I actually have 2 here for some reason. Delete that, that was incorrect. Okay. What the t-test will do is it's going to tell you if there is a significant difference statistically between these 2 means. So if you look at these means, 0.05 and 0.29, I mean, they're both under a gram. They're kind of small, like who cares? Does it really matter? Well, the t-test will compare those means in the data set, and it will tell you relative to those sizes and those proportions, is this statistically significant? And it's going to return a probability value. There's a lot more to the statistics behind this, which you'll learn in math class. But for our purposes, we're only going to be reporting on the p-value for this particular IA assignment. That is not the whole story. There's a lot more to it, but we're just going to go with the basics right now. So I'm going to skip a row, and here I'm going to type t-test just as my label. And then in cell A17, I'm going to type p equals, because using this function on Excel is going to return to me a p-value, which is a probability value. So it's going to tell me what is the probability that this difference in these 2 means is due to random chance, and what is the probability that the difference is actually due to a real difference in these 2 seed species. In this case, it's likely due to a real difference in these seed species because lentils and pinto beans are 2, completely different organisms. If it were, say, a pinto bean and a kidney bean, those are both different varieties of the same species. You might not come back with a significant difference. Okay, so this is the cell B17 where I want to record the results of my t-test. So to do that, I'm going to need to insert another formula. So I'm going to go back up to the formulas ribbon, more functions, statistical, and then I need to scroll down until I get to the t's and t-test, t.test, okay? And then if you click it, now we get a little bit of a different box. So it's going to ask you for array 1, array 2, tails, and type. Array 1 and array 2 are your 2 columns of data. That's all the array is. So for array 1, I'm going to left click, drag, and hold as I select all 10 masses of the lentils. And then I need to click in array 2. I'm going to left click, drag, and hold all the 10 masses of the pinto beans. Okay, so now I've selected my data, and you can see over here, it's telling the calculator all the numbers. And when you click in the tails box, it's going to tell you here, if you want a 1-tailed distribution, select 1. If you want a 2-tailed distribution, select 2. We're going to select 2. Don't worry about the statistics behind it. That's for a more advanced statistics class. For a biology class at this level, we're always going to do a 2-tailed distribution. If you click in where it says type, this one may change depending on how your data is organized and what your research question was. So if you look in the description here, 1 is a paired test, 2 is a 2-sample equal variance, and 3 is a 2-sample unequal variance. A paired t-test would be if we say we measured something on a human, say we measured a heart rate, and then we did something to that human, and then we measured the heart rate again, where we're measuring the same person and the change in the same person. That's what a paired test is. So say we made them like do some push-ups or something and then measured their heart rate again. So we're looking at the difference overall. We didn't do this because they're 2 different kinds of seeds. So instead, we're going to use number 2, and we're just always going to use number 2 for biology class for this assignment. And then you'll hit OK. And then down here, it returns a probability value. So if you look at it, 5.69, that looks like it's big, but it's actually not. E stands for times 10 to the, so this is in scientific notation. So it's 5.69 times 10 to the negative 12, which is actually quite small. And if I reduce it to our 2 significant figures, it'll be 5.7 times 10 to the negative 12. Interpreting a p-value, at present, the standard for p-value scientifically is if the p-value is less than 0.05, then it is statistically significant difference. Okay. If it's greater than, then there's no significant difference, and you need to use those words when you're analyzing your results. There are some problems here. You can Google it and read all about it. That's really just a 1 in 20 chance, which is kind of high. So there's a little argument about it within the scientific community, and there is a movement to push that p level down to 0.01 or even 0.001. But for this course, IB Biology, they're expecting us to use it at this level. So this is the magic number, so to speak, for you to interpret it for IB. When you get to college, that's another story. So we're almost finished. The last thing we need to do is insert a graph now, okay? So to do that, you want to tell Excel where your data is for this graph. So I'm going to left click, hold, and drag both of my columns of data. Excuse me, mistake. I'm going to left click and drag the means of both of my columns of data. We're going to make a bar graph because our independent variable, the 2 types of means, is descriptive. It's categorical, so we need a bar graph. So left click and hold the means. You only want to graph your process data, so the data where you've actually done some math to it. If you graph like I started to do all 10 trials, you don't actually get a good overview of central tendency of the data. It's cluttered, it doesn't tell you much. Students kind of like it when you do that because it looks fancy, but that's not the point of a graph. It's not to look fancy. The point of the graph is to tell you quickly a lot of information visually about your messy data set. So we want to left click, hold, and drag the 2 means. And then we're going to go up to insert ribbon, and we're going to insert a chart. And we want this chart here, insert column or bar chart. We're going to just do the first one. Later on, if you want to play around with some of these, you can. You can see we've got 3D charts, but really the simplest is the best. So just do a column chart here. I'm going to actually scale this down a little bit. We can see it on the same screen. And you can resize your chart on any of these. If you just hover, you can see the arrows. If you left click and hold it, you can change the size of your chart. Okay, now every chart will need a title and axis titles. So on the newest versions of Excel, you have a plus right here next to the chart if the chart is selected. If you click that, you also want to click the box for axis titles, and it'll put your titles there. So your chart title, see what I titled this, it needs to be something descriptive. So I just put massive seeds. I'm actually just going to cut and paste this for time's sake. And you'll notice on my error bars, or I've written a note about my error bars, that they represent standard deviation. That's important to include because error bars are a measure of your variability of your data, your variance, but they don't necessarily have to be standard deviation. They could be range, something like that. So this is just a note letting your reader know what the error bars represent. And then your axis titles, your dry mix, if you know that acronym. So the dependent responding variable will be on the y-axis. So the dependent variable was our mass. And then our mix, manipulated independent variable, should be on the x-axis. So I'm just going to cut and paste again. So our dependent variable is the mass. And it is important to include the units and the precision. I forgot to copy the G. And then over here, I'm going to put seed type. Right. So the next thing we need to do is change these labels that say 1 and 2 so that they match the lentils and the pinto beans. So how we're going to do that is we're going to click on the graph. So you know the graph is selected when you have these white dots on the edge. And then we're going to also make sure we click on the 1 and 2. And you'll know that is selected by these blue dots. I'm actually going to double click, and that's going to open up over here a window for us to use. So what we need to select here, they've actually changed it. Here we go, labels. Okay, apologies, the functions have changed a little bit. So we're going to click here and make sure that we have the blue dots selected. And then up here in the ribbons, make sure you have chart tools and then design selected. And then we're gonna click this one, select data. So you'll see here it says series 1 and then a 1 and a 2. So what we want to do is we want to edit the horizontal axis labels. So I'm going to click edit. And then again, we get this box that pops up. The axis label range is going to be over here, cells B2 and C2. So we're going to left click, hold, and drag. So it tells us, you know, here's the label here. And then you'll see lentils and pinto beans there. And we'll click OK. And then now we have that there. And the reason why we want to link all of this is you could use this as a template later on. Or if you say you made a typo, so say I didn't want pinto beans, I wanted lima beans. Well, if you watch over here, once I change this label, it will automatically be updated on the chart. Same thing here, maybe you made a data mistake, data entry mistake, and you put like 0.0269, you added an extra 0. Well, you can see now the graph automatically changed everything, it resized everything and put these in proportion. But, you know, if you had made a mistake, you can go back and you could overwrite that data and everything is all linked now. The very last thing we need to do is add our error bars. So if you select this graph, make sure the white circles are there and go back to the plus. We want to add error bars. Okay, so I'll check that box and it automatically adds some error bars, but those are incorrect. You got to be smarter than Excel here. You'll notice that the automatic ones, they're about the same size. We actually want to go to more options. It is not standard deviation. If we click the standard deviation, those are completely wrong. They're exactly the same size up and down, and that's not what we want. So we're going to go to more options. Make sure that they're going in both directions. We do want positive and negative error bars, and they should be centered around the top of the graph. The top of this bar should be your mean, and then the error bar up should be however many up your standard deviation is, and then the same for down. And I like the cap because they're easier to read, but some people prefer no cap. We want to change this from standard deviation, we want to select custom. This is probably the most tricky part of this whole process. And then we want to specify value. So here, we want to make sure this is selected. It needs to be highlighted or you need to delete it, one of the two. If you don't, you're going to have an error. But we want to highlight the 2 standard deviations. So left click and drag where your standard deviation is. Okay, and you should see this green dancing line down here. And for the negative error value, the same thing. You either want to highlight or delete that. And you're going to select the same thing. What we're doing, in effect, we're going to left. Okay, I have to actually click in the box so I get a cursor. And a left click, drag and hold over the same 2 standard deviations. We're telling Excel, draw a line that goes up from the bar by exactly 1 of this value and draw a line that goes down from the bar by exactly 1 of this value. And now you can see your error bars, okay? And you can tell they're correct because they should, this one should, on the lentils should go up by 0.008, okay? So it should be much smaller, up and down, and the pinto bean should go up by 0.04, much wider. One way you can look to see quickly is if this is statistically significant or not, is there an overlap in the error bars? And there is not in this case. There's a huge difference in the means and the error bars do not overlap. So it's probably safe to say that there is a statistically significant difference. And we did a statistical test to show, give evidence in support of this statistically significant difference. Now, this is complete. You don't need to have these notes on here. I'll just delete them. Okay, I'll delete that one. If you were going to include this now onto a Word document for when you type your report, what you'll need to do is probably include grid lines. These grayed out lines won't show when you print them out, so left click and select. Actually, I'm gonna select all the way down, and to include your grid lines, it's this button up here on the home ribbon. Select all borders, and so now you have a nice black borders all the way around, and you can just copy and then paste it into a Word document, or you can select here, copy, and paste this into a Word document as well. They'll both directly transfer. You can also play around with the graph if you would like. You can change colors and things like that, but just remember, simpler is best and more readable is best, okay? And that's how you do a table and a graph for and statistical testing for descriptive statistics and a student's 2-sample t-test.